Hello everyone, welcome back to Smart Interviews YouTube channel. So today we will be solving few problems from Codechef Starters to 1-1. Without any delay, let's start solving. Right, so let's start with the first problem of the day. The first problem is known as fuel check. Let us go through the problem statement and try to understand what exactly we have to figure out. So there is a person known as Chef. Chef plans to go on a long drive and is now checking whether he has enough fuel for the trip. Basically, Chef is planning to go on a long drive and he has to check if he is having enough fuel in the tank or not. So Chef's car has X units of fuel remain. Right, there will always be X units of fuel remain. The car has fuel efficiency of Y. The car has fuel efficiency of Y. This statement denotes that for 1 unit of fuel, the car can go at most or travel at most Y units of kilometer. So if you see, the same thing is written here, meaning that for each unit of fuel, it has or it can travel a distance of Y kilometers. Right? So if I have 1 unit of petrol and if the efficiency is 5, I can travel 5 kilometers with 1 unit of petrol. I hope the problem statement is clear. Now let us try to figure out what exactly we have to find out. So Chef knows that the distance he needs to travel is exactly 100 kilometers. So Chef knows that we have to travel exactly 100 kilometers. We have to figure out if he has enough fuel to complete his trip or not. Now the distance is already predefined. Distance is exactly 100 kilometers. It will never change. Chef always travels 100 kilometers. All you have to do is take the help of X units of fuel and take the help of Y units of kilometers and figure out if Chef can travel 100 kilometers or not. Right? So I guess the problem statement is clear. So you can pause the video here and try to think of multiple solutions here. Try to figure out the solution on your own. Later, if you were unable to figure out the solution, you can unpause the video and figure out the solution with me. Let's move forward to the solution. Before moving forward to the solution, let's discuss few sample test cases. If you see, you have X as 10 and Y as 30. Now, according to our problem statement, we know that if I have 1 unit of fuel, I can probably travel Y kilometers. Or if I put it in a different way, it is 1 into Y kilometers, because we have exactly 1 unit of fuel. Now, by looking at this, what can we do? If I wanted to travel for 100 kilometers, and if I have exactly 10 units of fuel left in my tank. So the fuel is 10 units, but the vehicle efficiency here is 30. So my vehicle can travel 30 kilometers for a single unit of fuel. If you see, I have 10 units of fuel. Can I simply say, in order to figure out the total number of kilometers that I can travel, all I have to do is multiply 10 with 30, which is basically 300 kilometers. So right now for this example, can I say we can travel for 300 kilometers? And according to the problem statement, we just only have to travel 100 kilometers. So we can easily complete our trip. So for this example, you will have to print yes. Let us quickly look at the other examples as well. If you see, for this, it is, can I say you have 20 units of fuel left and your fuel efficiency is exactly 4 kilometers. Can I say that now it changes to basically 20 into 4, which is how many kilometers? Which is exactly 80 kilometers. But according to the problem statement, we have to travel 100 kilometers. If you see, we don't have enough fuel to cover or enough efficiency to cover 100 kilometers. So the answer for this input would be no. you cannot cover 100 kilometers. Can you guys also quickly tell me what would be the answer for this example? As it is very straightforward, you will simply do 5 into 20, which is basically 100. That means that you can easily travel 100 kilometers. I hope everybody is clear with the problem statement, and I hope everybody is also clear with the solution. So now let us move forward into coding up the solution. So if you see, we have the problem statement on the left side and we have the coder part on the right side. Let us quickly go through the input and output format. The only line of input will contain two spaces generated by x and y. Basically, you will be only given x and y, and output should be either yes if chef has enough fuel, and either no otherwise. So if you can see, let us also look at the constraints, because it sometimes plays a very crucial role. Constraints are very less, so whenever you are multiplying values, it will not exceed the integer range. And these are the sample test cases. We have already gone through the sample test cases. If you want, take a moment and you can pause the video here. You can try to write the entire solution on your own. If you're stuck anywhere, you can refer to the code that I'll be writing in the next 1 minute. Moving on to the code. So let us start by writing the scanner class. Scanner SE equals to new scanner system.in. So according to the input format, we know that we have to take two values as input. Let us take int x equals to sc dot next int, and we also need y. So what do we have to do? We have to check if x into y is greater than or equals to 100. Basically, you can simply write x into y if x into y is greater than or equals to 100. When you have enough fuel, when you have enough kilometers, all you have to do is print yes. Coming down to the else part, when you don't have enough kilometers, obviously according to the problem statement, you have to print no. Did we miss anything? No. So let us try running the code and see if it is working as expected. And this needs to be capital N. Right. So for 10 and 13, the output should be yes. If you see, for 10 and 13, the output is yes. Let us try submitting it. As you can see, it got successfully submitted. So let us move forward to the next problem as well. Moving on to the next question. So the next question is buying chairs. Chef is redecorating his house and is trying to decide which chairs to buy. He's basically trying to redecorate his house and he want to buy few chairs, but he can't decide which chairs to buy. Now in the furniture store where chef is visiting, we have W number of wooden chairs and P number of plastic chairs available. So chef believes that each wooden chair will increase the stylishness of his house by 2, while each plastic chair will increase the stylishness of his house by 1. So he thinks that having a wooden chair, increases the stylishness of his house more than having a plastic chair. Basically, having a single wooden chair increases the stylishness by 2, and having a single plastic chair increases the stylishness by 1. Now, chef wants to buy exactly k chairs in total. He has to buy exactly k number of chairs in total. It is guaranteed that we have it is also given that it is guaranteed that k will be always less than or equals to number of wooden chairs plus number of plastic chairs. So every time you can pick up k number of chairs. Now at the end of the day, you have to find the maximum possible stylishness chef can attain by purchasing exactly k chairs from the store. So you have to figure out the maximum stylishness that chef can attain by purchasing exactly k number of chairs. So let us try to understand this problem statement in more depth by looking at few examples. So as you can see, we have W, P and K. W resembles number of wooden chairs, P resembles number of plastic chairs, and K is total number of chairs that chef needs to buy. And we are already aware that a wooden chair increases the stylishness by 2 and a plastic chair increases the stylishness by 1. Right. So if this was the input, or if this was the available chairs that we have to buy, we have exactly 9 chairs that we can buy, out of which 4 of them are wooden chairs and 5 of them are plastic chairs. In this scenario, what do you think chef would do? So one thing we can do is we can buy 5 plastic chairs and a single wooden chair. That means 5 into 1 would be the stylishness that I'll have, because each plastic chair has 1 stylishness. So it is basically I have 5 stylishness plus I am buying a single wooden chair, which is of course 1 into 2, basically 2. In total, after buying exactly k number of chairs, the stylishness would be 7. The stylishness would be 7. But is this the best stylishness that chef can buy out? Can you guys try to think of some other combination? Right. If you see, according to the problem statement, we have to find the maximum stylishness. So let's see if there exists any other combination. Now, chef can also buy 4 wooden chairs. Chef can also buy 4 wooden chairs. That means the stylishness increases to 4 into 2, which is basically 8. Now, out of 6 chairs that he has to buy, he has already bought 4 chairs. He has 2 more chairs left over to buy. So if I wanted to increase the stylishness, I would still give the preference to wooden chair because it has more stylishness. But as we have already bought all the 4 chairs, we have to definitely take the chairs from the plastic chairs. So can I say you will buy 2 plastic chairs which is having a single stylishness. So it will give us a weightage of 2. Now can I say in total, the entire stylishness is basically 10. Now if you see, it was better than our previous stylishness, which was 7. And can I say, so far, if you figure out any other combination, so far 10 would be the best combination that we'll ever get. So the answer for this would definitely be 10. You have to print the maximum stylishness that you can attain. Let us try to figure out the answers for all the other examples as well. If you want, you can also pause the video and write down the solutions for them and later cross verify them once I discuss them. Right, if you see, chef can only buy 2 chairs here. So out of there are 9 chairs. So he can buy either 2 wooden chairs or either he can buy 2 plastic chairs. But as we want the maximum stylishness, we would obviously give the preference to wooden chairs because it has more weightage. Can I say chef simply buys 2 wooden chairs, which is basically nothing but 2 chairs into 2 is the stylishness? Can I say in total 4 is the maximum stylishness that chef can attain? Yes. So this becomes 4. Now for the third example, chef needs to buy 9 chairs. So can I say definitely in order to have more weightage, I would definitely buy this 6 chairs. Yes. And if you see 6 plus 3 is giving us 9. Can I say this is the only option left for us? Right? The maximum stylishness that chef can gain for this example is 6 into 2, 6 wooden chairs into its stylishness is basically 12. It is 12 plus 3. 1 into 3 is 3. So can I say in total it is 15 here? Right. Now I think this is a good example. If you see, chef has to buy 3 chairs. So can you guys tell me for which chairs would he give the preference? He has exactly same number of wooden and same number of plastic chairs. As we need the maximum stylishness, he would definitely give the preference to wooden chairs. So can I say it is simply 3 into 2, which is 6. Right. So if you are clear with the problem statement and also if you are clear with the examples, you can try pausing the video and try to come up with different kinds of solution and see if you can maybe solve the question on your own. Alright, let's try to discuss how exactly we can solve this problem. Now, can I say from all of these examples, we have figured out that if there are any wooden chairs that chef can take, chef would definitely give the most preference to the wooden chairs because it increases the stylishness more. Right? It increases the stylishness more. So let's say if there are five wooden chairs and chef has to pick only 2 chairs. Forget about the plastic chairs. So chef has to only pick 2 chairs. Can I say definitely he would give his most preference to the wooden chairs? Alright. Can I say it is the same case when you have to buy 3 chairs as well? Can I say it is the same case when you have to buy 4 chairs as well? Irrespective of the number of plastic chairs that you have, you would still give the most preference to this. Alright. Even if I wanted to buy 5 chairs, I would still choose five wooden chairs in order to increase the stylishness, in order to have the maximum stylishness. Right? So if I need to buy 6 number of chairs, do you see that I can't exactly buy 6 chairs only depending upon wooden chairs? Can I say in this scenario, I will definitely depend on the plastic chairs as well, right? But as you see, till this point, we did not even worry about having plastic chairs, right? So can I say, basically, basically, if your number of wooden chairs, is less than or equals to the total number of chairs that you have to buy, can I say definitely you will buy k number of chairs from the wooden chairs? Yes, of course. Yes, of course. Right. Now, what would be the other condition where we have to, take the weightage of plastic chairs as well? Whenever if the if the chairs that you have to take are more than the wooden chairs, right? If the chairs that you have to take is more than the available wooden chairs, in this case you have to take a little contribution from the plastic chairs in order to sum up the entire total chairs to k, right? Can I say it basically depends on both of these conditions? Right. Now let's try to figure out the answer for this example. Let's try to figure out the answer for this example. So can I say if you have to buy 10 chairs and there are 3 wooden chairs available, you will definitely buy all of these 3 wooden chairs. If there are 5 wooden chairs, you would still buy all of these wooden chairs. Yes. So can I say here, if you are trying to find the answer here, can I simply say that answer here basically becomes W into 2. Yes. If you can pick up wooden chairs out of K total chairs, you will definitely pick up all the wooden chairs that you can pick up, right? So that is the reason why we are simply writing it as W into 2. This will ensure that we are taking the maximum possible stylishness from the wooden chairs. But if you see, even after taking W number of wooden chairs, K wouldn't sum up to the total chairs wouldn't still sum up to K. Can I say we would have to take the help of plastic chairs here now? So if I've taken W number of chairs from K, if I'm taken W number of chairs from K, can I simply say I have to pick K minus W, of plastic chairs? Yes, we have to definitely pick K minus W of plastic chairs. So can we simply write the formula as K minus W number of plastic chairs I still have to pick, and the weightage here is of course into 1. Can we ignore this into 1 because it would be the same value anyhow? Can I say if the total number of chairs that you have to buy is greater than the total number of wooden chairs that you are having, you would pick up all the other wooden chairs and then you will buy the extra plastic chairs. Can I say this is the answer if this is the condition? Now here, instead of writing another if condition, we can simply write it as else. What do you think we would have it in the else case? We would have answer is equals to, now let's say in this case K is less than or equals to W. It enters the else condition when K is less than or equals to W. Basically you have more number of wooden chairs than the K number of chairs that you have to buy. So in order to have the maximum stylishness, obviously you will give the preference to W. So can I say you would directly take up all the wooden chairs and simply do W into 2 here? Yes. So if you guys understood this solution, can you guys try writing the code by yourself? Okay, moving on to the writing code part. Right. Now let us once first go through the input format as well. As you can see in the input format, the first line of input will contain single integer t. Basically there will be different types of test cases. So we have to write a loop separately for t. And as you can see, the first and the only line of each test case contains 3 space generated integers wp and k. Right, wp and k. Now we have to take the input for t, which is sc.nextInt, and we have to write a test cases loop for t. So while t is greater than 0, alright. Now we have to take 3 inputs. Let's start by taking w. So W, P and K. So what would be the first if condition that would be writing? So if K is greater than W, if you have to buy more number of chairs than the total number of available wooden chairs, you would need to pick few chairs from P as well. Now definitely we will write here system.out.println. From the formula that we got, we will, can I say this is the formula which works for this solution? Yes. So we can simply write it as, you will pick up all the wooden chairs that are present. You'll pick up all the wooden chairs that are present, plus you will be picking up exactly k minus w number of plastic chairs. It is simply into 1 here, but we can ignore it because it is irrelevant. I'll still write it because it makes the code look clean. Alright. So in the else part, we figured out that if the wooden chairs are exactly, if you can pick up more wooden chairs, if you are having more wooden chairs and if you are having less chairs to be picked up, you will definitely consider this case. So in this case it becomes, you can copy down this line, right? In this case you will definitely pick up all the wooden chairs that are available to you. Let us try running this code and see if it is working as expected. As you can see, we are getting 10 and we are getting 8, we are getting 15 and we are getting 6. So if you can see, for second example, we are supposed to get 4, but we are getting the output as 8. What do you think might be the reason here? Let us look at the example once again. Now if you see, for the second example, let us see what exactly is happening for this condition. In the second example, you have k, which is 2 as the total number of chairs that you have to pick. Now, so is 2 greater than the total available wooden chairs? No. So obviously it won't enter into this. Now when you are moving down to this, as you can see, you have 2 chairs but you are trying to pick up 4 chairs. So should this be w into 2 or should this be the number of chairs that we can pick up? Right. So this shouldn't actually be w into 2, this should actually be k into 2 because k is the least amount of chairs that we will be able to pick up. Right. So if we make the small change here, it would definitely work as expected. Alright, as you can see, the output and input is matching now. Let us try to submit it. So if you completely understood the previous problem and if you successfully submitted the solution as well, let us now move forward to the next problem of the day. Now the next problem's name is wolf dung. So as you can see, there will be a certain forest which has n animals living in it. Each animal can either be a wolf or be a bird. So it will be any of these two animals. So all the animals live in a straight line. They basically live in a straight line and position from 1 to 3 and so on up till n on the x-axis. Now you are given a binary string of s of length n. As you can see, according to the problem statement, s of I is 0 means that the animals living at the ith position is a bird. And if s of I is equals to 1 means that the animal living at that position is a wolf. So if it is a 0, it is a bird, and if it is a 1, then it is a wolf. Let's see what we have to do with this. Unfortunately, the wolves like to eat the birds. Every second, the following will happen. Now, for every position x, such that let's assume if there is a wolf present at the xth position, and let's also assume that there is a bird at x plus 1th position. The wolf at position x will definitely eat the bird which is exactly next to it at x plus 1th position. After eating the bird, the wolf will move to position x plus 1. While we will be discussing the examples, I think you will exactly understand what they are trying to explain for every second. Now, note that they have also mentioned that note that the birds never move. A wolf that does not eat a bird does not move. Basically, if a wolf cannot eat a bird, it will not move as well. And each wolf eats at most one bird in every second. A bird is called safe if it never gets eaten by a wolf. Now you need to figure out how many birds in the forest are safe. As this is a lengthy problem statement, if you guys understood all of the important things or key points from this problem statement, let us try to understand more about this problem statement by discussing few examples. Right. So basically you will be given this kind of an input format. You'll be given the length of the string and you'll be given a string according to the problem statement. Now if you can see in the problem statement, they have told that for every second, if there is a wolf, we know that 1 is a wolf. We know that 1 is a wolf and we know that 0 is a bird. So if there is a wolf present at xth position, it will eat the bird which is present on x plus 1th position. It will eat the bird which is present on x plus 1th position. So basically it will eat up this and this one will move to this position. This one will move to this position. So let us try to simulate what happens for this string for every second. Let's assume for the first second, let's figure out what happens. Now as you can see, there are two wolves. Now this, let's assume this index as, let me write down the indexes as well, 0, 1, 2, 3, 4. Now you have a wolf at the 0th index, you have a wolf at the 3rd index. So every second, all of these wolves act parallel. It's not that first this wolf will move, then later this wolf. All of them will act parallel. So let's see. For the first second, what happens is this wolf will eat up the bird which is present at its next position. So as you can see, this bird gets eaten up, and according to the operation they have mentioned, this wolf again moves its positions to x plus 1. So let us write this index as 1 for now. Right. Let's move forward. If you see in the same second, even you have another wolf to which exactly after the wolf you still have another bird. Now what happens here? Same thing which happened here. This wolf will also eat up this bird. Now this wolf eats up this bird and the wolf which is present in index 3 now also moves to index 4. So technically after second one your string should look something like this, right? Assuming that from this indexes the wolves have been moved, I've still written it as 1, just showing us that there might be a wolf there, right? Now at second 2, what happens? There is a wolf here. So if I assume this as the xth position, exactly at x plus 1th position, I have a bird. So the operation repeats. This wolf eats this bird and it moves forward like this. Basically, it moves forward like this. As you can see, at second 2, do we have any safe birds? No, we do not have any safe birds. All the birds were eaten by all the wolves that are present in the forest. So this is what they are asking us to find. So for this example, can I simply say there will be no safe birds present after a certain amount of seconds. So you should print the output as 0. I hope everybody understood what I'm trying to explain here. Okay, if you understood the explanation, can you guys quickly tell me what would be the answers for this? Alright, as you can see, there are only safe birds here. There is no wolf to eat these birds. Can I say the answer for this would be 3, as there are 3 number of birds which are not being eaten up and which are safe. Alright. What about this example? For this example, obviously there are 4 wolves, but there are 0 birds to get eaten up. So can I say for this example there will be 0 safe birds, as there are no birds present in the forest. There will be 0 safe birds present. Alright. I hope everybody understood the problem statement, and I hope you also got a good clarity over the problem statement with these examples. So try to pause the video and try to think of different solutions on how you can approach or solve this problem. Okay, so let us discuss another case which I think would help us solve this problem. Now, if you have a string like this, right? So we know that this is the only wolf that is present, and we also know that if a wolf is present at xth index and if it eats a bird, this wolf will only move to x plus 1th position. So that means this wolf will never worry about all the birds that are present before its index. Alright. Now, when this wolf actually eats this bird, what exactly happens? This bird gets eaten and this one moves to this index. All of this happens in the first second. Alright. In the second, what happens? The same scenario. You have a wolf at this index. Now, beside to that wolf at x plus 1th index, you have a bird. So definitely this wolf will eat up this bird. Now again the same operation repeats. It will get eaten up. The wolf present at xth index will move to x plus 1th index, which is this. If you see, if I repeat this process for 2 more seconds, basically at second 3 and second 4, how do you think the string would look like? Definitely this one wolf will eat up all the other birds that are present on its right side, because we know that once a wolf eats, it moves to its right side. As you can see, these birds were never been eaten by any wolf, because there is no wolf present before these birds to eat them. So are you able to understand how this simple example is trying to help us solve the problem? Yes. So let us take another small example. If I have a single wolf, can I say, and if I have some x number of safe birds here, irrespective of the number of safe birds here, can I simply say, in this case, there would be 0 safe birds, as this one eats up all of these values, as this wolf eats up all of these birds, right? Now let me make a small change to this example. So if I add a bird before the wolf, can I say this bird will always be safe? Right. So if you have few more birds like this here, can I say, as this is not been eaten up by any wolf, we can consider it has a safe bird. So let us say the count is 1 for now. So the count is 2 here. As this is also safe bird, the count is 3 here. As this is also safe, the count is 4 here. Now when I come across this wolf, can I surely say that if there is a bird here, it will definitely eat up, this wolf will definitely eat up all the other birds which are present after that wolf? Yes, definitely. So can I say, if I come across a 1, can we simply stop checking for all the other birds which are present on the right side of that one? Yes, because we can guaranteedly say that this wolf will eat up all of these birds. Now you might say that there might be a case that there might be another one like this. So in this scenario, what happens? This wolf eats up this bird, you stop it. This wolf eats up this bird, you stop it. So there are no more safe birds present after this one. And you might also say that what if these were all ones? Even if these were all ones, can I say this answer would still remain same? Yes. So let us try writing the code for this and figure out what we can do. So if you come down to the code part, as you can see, let us first go through the input format and output format and also look at the constraints. The constraints are very less, so you need to have a very straightforward solution. Now, by looking at the input format, we can say that you can have an integer t. Basically, you will be having test cases. Now, for each test case, it consists the first line consists n, basically a single integer, the number of animals in the forest. The second line contains binary string s of length n, denoting which animal is present at which position. So you have to take two inputs. Now have already have the test cases loop written for me. So you have to write a scanner statement, read the number of test cases that we have to run the solution for, write a while loop for test cases. After this, the first line would be n, which is the size of basically the forest or number of animals present in the forest. And then the next loop would be the string that we'll be getting. So we will be taking it as sc.next. Now, according to our solution, we discussed that we will simply take the count of these zeros until we find a 1. Now, what if there was a 1 here? Would there be any safe birds for this example? No, there would be 0 safe birds. So initially what we can do is we can initialize a count which stores the number of safe birds as 0. Then later run a for loop starting from I equals to 0 to I less than n and I plus plus. So now what do I need to do according to our solution? I need to count the safe birds until I come across a wolf. So can we simply write it as if str.char at, I have to see what animal is sitting at the ith position. So I'll simply check if str of I is equals to 0. So if it is a 0, we know that it is a bird and no other wolf has eaten it so far. Now else there would be only one other case, which is basically encountering a wolf. Can I say as discussed here, we can simply stop counting the number of safe birds now? Yes, after reaching if this one was not present, after reaching this index, we definitely know that if there were any safe birds here, those safe birds will be being eaten up by this wolf. If there are no safe birds also, the count still stays as same. So in the else part, we can simply break the loop and stop counting the birds, because definitely it would be eaten up by that wolf. Now at the end, according to the problem statement, we just have to print the number of safe birds. Let's see if it is working as expected or not. So for the input that we have, our output should be 3001 and our output is 3001. Let us try submitting this. Right, as you can see, the solution is working as expected and we have passed all of the test cases. So if you understood the solution for this problem. Let us move on to the next problem. So let's move forward to another problem. So the another problem is known as 𝗨𝗹𝗃𝗃. Now let us try to first go through the problem statement and then later understand the problem better by going through the examples. So they've they're basically giving us an array A of length n. We define f of a as follows. So they are giving array A and of length n, and they are asking us to define f of a. So in order to define f of a, we have to follow a few things. So they are asking us to say that, let's say S denotes the sum so far and H denotes the happiness initial. So initially we can consider both sum and H are both has zeros. Then for each I for 1 to n, so for each I from 1 to n, we have to perform something. Now if you see, if S does not double up upon adding a of I to it, add 1 to your happiness. So if you have an initial value as S, and if it does not double up after adding a of I to it, you need to add one value to your happiness. That is basically nothing but whatever is mentioned over here. S of S plus a of I should not be equals to 2 into S. In this scenario, you just need to add 1 to H. Also note that if S plus a of I is matching with 2 into S, you should not change the H value. You should not do anything else. And right, if these conditions are done and satisfied, at the end of the day, you should still add the sum value to a of I. You should still add the sum value to a of I. So f of a is then defined to be the final value of H. Basically, whatever value that you're storing or whatever f of a that you'll get is known as the final H value. You have to, according to the problem statement, you have to maximize this f of a value. In a sense, you have to maximize the H value, which is basically the happiness value. They have also mentioned something at the end of the problem statement, saying that find any rearrangement of a that maximizes f of a. If there are multiple rearrangements that maximize f of a, then any of them will be accepted. So they are hinting us towards that there can be multiple answers for this, and any answer can be accepted. Okay, so if you got a good understanding over the problem statement, so we can understand about it in more depth by looking into few examples that were provided in the contest. So let's see. So this was, I guess, the second example. For this second example, they are saying that the output should be 231. Now they have already mentioned that the output shouldn't be exactly 231. It can also be some other value, some other arrangement if it is present. So let's first understand why the value 231 or why the arrangement 231 works. So if you see for the arrangement 231, let's have an initial sum value as 0 and let's have an initial H value as 0. Now they have told that we have to have a one based indexing. Basically this will be one based indexing. So according to them, you have to see if S plus a of I, if it is not matching with H, you need to basically increment the value of H. Right? It was, the problem statement is something like this. And irrelevant of this, every time you will add a of I to your sum value. Yes, I hope this was just given in the problem statement, and I hope everybody is clear with this. Alright, okay, let's try to see if what is the f of a value or happiness value that we are getting after processing the output. Now if you see, for s equals to 0 and h equals to 0, initially what we will do, when the index I is equals to 1, you will basically check if 0 plus 2 is not matching with 2 into S. What was S? S was initially 0. So basically 0 and this becomes 0. So we know that 2 is not matching with 0. That means the value of h changes to 1. And after changing the value of h to 1, we also need to add a of I value to s. So after this operation is done, you will update the sum value to 2 because a of I is 2. Right, moving forward. When I value is 2, you need to basically add the same thing, sum plus a of I. So sum here for us is 2 now. So you will do 2 plus a of I is now 3. So 2 plus 3, it shouldn't match with 2 into s. So if you see sum's value is 2, so 2 into s would basically give us 4. And as you can see, this sum is giving us 5, where 5 is not matching with 4. Can I say we are this condition is true? If this condition is true, we have to increment the value of h. So that means h value now gets updated from 1 to 2. That is the same thing that was represented here, adding 1 to h. Alright, let's try to continue the dry run and see where we are landing. Now if you see, for I equals to 3, basically the previous sum value, we need to add a of I to the sum, right? So basically the sum value should be updated to 5. Now the previous sum value is 5, the current a of I is 1. You should see if it is not matching with 2 into s. S should be previous sum value. Previous sum value was basically 5, so 2 into 5 is 10, and it will definitely not match. The h value now becomes 3. So if you see in the question itself, even in the explanation, they say that the final value of f of a needs to be h equals to 3, and they have given a statement that it is also proved optimally. Now you can try figuring out some other ways to rearrange these values such that maybe if there is a chance that h value can reach more higher happiness. But according to the problem statement, they have already mentioned that this is the most optimal rearrangement or the happiness value that you'll get. So now if you look at the second example, can you guys try to perform the same kind of operation here and figure out what is the happiness value that you're getting here? So if I try to perform the same thing here, let's try to perform the same thing. So for this you have 2, 4, 6, 2. You have the output is 2, 4, 6, 2. So let's figure out the happiness value for this. Now you have 1 based indexing. So s is initially 0, h is initially 0, right? Now when I is equals to 1, what happens? You will check if s plus basically 0 plus 2, is it not matching with 2 into s, which is 0? Is it matching? No. So happiness value changes to 1. Now when we go to I equals to 2, we also update the s value before moving to the next index, right? So s value should be updated to plus a of I, which is 2. Let's move forward. When I is 2, you will do 2 plus 2 is the previous sum and a of I is 4. You will see if it is not matching with 2 into s. 2 into s should be basically 4. This is summing up 6 and it is not matching with 4. So that means happiness value increases once again. Let's move forward, but before moving forward, let's update the sum value to 2 plus 4, which is 6. And if you continue this order, you should be getting the h value as 4, and which is the most optimal happiness value that you can get. So they are expecting us to provide this kind of rearrangement. If you guys understood the problem statement, if you guys understood the problem statement and the examples, you can pause the video and try to think how you can solve this problem. So a good way to solve this problem is, while reading the problem statement, we understood that this isn't always the answer, or whatever the output that they have given in the sample output is not always the answer. There can be multiple rearrangements, right? So we have to find the rearrangement which will always give us the highest happiness, right? So how come, when do we get the highest happiness? When do we increment the value h? We are incrementing the value h whenever these things are not getting matched. Whenever the formula is not being matched, we are incrementing the happiness value. So we have to somehow rearrange the value such that the formula will always work. Now a best way to do this is, if you have, let's assume 1, and let's assume you have few more values, and let's assume the last value is 7. Instead of 1, let's take 2 for better understanding. You know that you have 2 and 7. Let's have 3 and 6. If you see here, now when you are having sum as 0 and your happiness is also 0, if you consider this as the first index, you basically know that when I equals to 1, your sum value will not match, the condition will fail, then the happiness value gets increased to 1, right? Then later you will be adding 2 to this answer, 2 to this sum value, right? But let's assume instead of 3 here, if you had 2 here, right? So for the next iteration, what would happen? Your previous sum value is 2, and you are adding the current sum value, current A of I value. Current A of I value at second index is value 2 itself. So when you add 2 to this, it becomes 4, and it shouldn't match with 2 into S, right, which is also 4. Do you see that if you are considering the values in a sorted order, if you maybe have few more 2's like this, and if the entire array is in sorted order, do you see that if you take adjacent values, the condition will always be wrong? Yes, it might pass for the scenarios where 2 is not matching with 6 and so on, but still there might be higher chances that the happiness condition won't ever get executed, right? So what can be the best ordering that we can do? Let's assume as we want to add a certain value to the previous sum, such that doubling it will never match with the 12, now if you see, if I have the previous sum as 2, and if I add A of I basically as 7, if I try to add 7 here, it becomes 9. This sum becomes 9. Is it not matching with 2 into S? 2 into S in our case becomes 4. Do you see that it is not matching? Right. So we considered 2 and then we considered 7. Let us now try to consider the same 2 again, and let us this time, instead of considering the next 2, try to consider it as the 6. So if you see, we are always picking a different value. We are sometimes either picking the smallest value, or we are sometimes either picking the largest value. We are doing this because we are making sure that even if there are duplicates like this, even if there is some other value, doubling the previous sum will never end up having the same value or the same sum value as adding the current a of I value to the previous sum. We are making sure this condition, we are making sure the condition sum plus a of I is always true, which is not equals to 2 into s. We are making sure that this condition is always true by arranging the values such that we always pick the smallest value and we always next add it up to the highest value. Then we again pair it up with 2, then we again pair it up with 2 and 6. Then we again have 2, then we again have 2. If we are following this kind of rearrangement, it is bound to always give us the optimal solution because this condition will always be true. So let's see if that is also a valid response here. Now for this the output for 213 the output is 231. But according to our solution, if you have the entire thing in sorted order, it is 132. So that means we will try to pair up 1 and 3 first, then later 2. So that means the output should be something like 1, 3 and then 2. If you try to find the happiness value, or f of a value for this will still give us the same value as this. And it can be the same here as well. You can also rearrange this 4 2 6 2 something like this. If you sort it, it becomes 2 2 4 6, and if you are going with the rearrangement that we discussed, it becomes 2 6 and it becomes 2 4. Are you guys able to understand how we are trying to solve this problem? We are just placing the pointers like this. We are printing 2 and 6. We are again moving inward like this. We are printing 2 and 4. We are moving inward like this. I hope the solution is clear to everyone. Shall we now move on to the code part? If you want to write the code on your own, you can pause the video and try out the solution by yourself. Okay, let's now move down to the code part. Now if you look at the input format, we have t number of test cases, we have array and n. Basically n is the length of the array and we have the array elements, right? If you look at the constraints, there can be 10 power 5 test cases and 10 power 5, the length of the array can be 10 power 5 and a of I can be 10 power 9. We are not dealing anything with sum in our actual solution, but if you were writing a solution which revolves around sum, definitely you might need to convert the data types into log, right? So according to our solution, let us try to write the code for the solution. So you are taking t. I've already written the format for writing the scanner class and writing a loop for test cases. After this, first line of input would be your length of the array. Then you will need to declare an array of size n. The array size is n. You will need to run a for loop and take the input into the array. So array of I is equals to 𝗟.next int. Right. Once you are done with this, according to our logic, we will be sorting the array. So we can simply do arrays.sort arr. This will sort the array. Now we have to always pair up the smallest value and highest value. So we can have two pointers like this: int I equals to 0, int j equals to n minus 1. After this, we have to pair them up, right? We don't have to store them anywhere. We can directly print the answer. So while I is less than j, you need to write system.out.print. You need to print array of I. Let's give a little space here. Let's try to print both the values at the same time, so we will not face any difficulties. We are printing array of I. We are printing smallest value and highest value. Later you will increment I pointer and you will decrement j pointer. So is there something that we might end up missing due to this while condition? If you see, if it was an even length array, while when I is matching with j, we might miss. Sorry, when it was odd length array, when I is matching with j, we might miss printing the odd element out. So for this specific case, you can do something like if n value is not equals to 0, basically that means it is an odd length array, and we have to handle a specific case where we print out the element pointing to I or j. So basically I and j becomes the same thing, so you can print any value here that you want to have. Either you can print array of I or either you can print array of j. Once this is done, it is better to write print ln here, because that will be there will be multiple test cases here. So if everything is right, let's try running the code. Okay, it is giving us the output. It is giving us 132. 32 is getting mixed up, in a sense after 3 you are not getting extra space. Basically you need to add an extra space here. Alright, okay, we are getting the output here. Let's try to submit it and see if it works. The submission got queued. Right, we got the answer as correct answer. So as you can see, we basically solved 4 questions today in Codechef Div 4 contest, and if everybody is clear with everything, you can try solving the next problems by yourself. You can always take the help of editorials that are being posted in Codechef. So that's it for today's video. If you learned anything new today, make sure to like, share, subscribe to Smart Interviews YouTube channel. See you again in the next video.